Now let's come to the components of database management system. Components means what are the things required for a database system. You see, any effective database system will comprise of four main components. One is the data, one is the hardware, one is the software, and one part is the users. Now, data we have talked about a bit in the beginning. So let's come to inside database management system and what is data here. It is the most crucial component of database, and real world applications demand storing and processing of large amount of data, which are often accessed by different kinds of users through application programs. Now, there are two types of data that a database stores. One is the user's data and metadata. I've just talked about metadata also. Now, user data contains data to support users' applications. Metadata, on the other hand, stores data about data. It describes the structure of the database and includes information regarding the number of tables required, table names, number of fields, field names, primary key fields, types of predefined queries, etc. So this is all what are the role of data which is played inside the database. Now, what is hardware? We all know hardware and software are two different parts which are very essential. In database management system also we require a hardware. Now, hardware, it will consist of the secondary storage device on which the data is stored, input and output devices for receiving or giving data to users, and processor and main memory for processing the data in a fast and efficient manner. Since a database system can be either deployed on a desktop computer with a single user or on a mainframe computer to be shared among thousands of users, the hardware which should be chosen must meet the database requirements. So that is the essential part, that the particular configuration or the particular hardware configuration will be chosen to meet a particular database requirement. Now the next part, that is the software. Now what is the software all about? We know we deal with a lot of many softwares. So here software consists of the database management system, which will act as a bridge between the user and the database. The database software will interact with the user's application programs and database to insert records, update data, delete data, and retrieve data. So a DBMS is responsible for maintaining the integrity and security of stored data and for recovering information in case of system failure. So we have talked about this integrity, data integrity. Data integrity is where even at multiple places, if the data is shared among various users, the data will be same throughout. The data will be integrated stored in an integrated manner. What security? The data stored will be secured enough that you can rely on the data, you can be confident about the data, there will be no unreliable data. So you can very well understand that the data stored will be much more secured, because as we have discussed earlier, that the various kinds of access permissions are given to various kinds of users. A database might have various kinds of users, and all users do not have the same kind of access permission. Just as I told you, there are three kinds of permissions: read, write, execute. Some users might have only read permission, some users might have read as well as write, some might have all the three permissions. So depending on the user's working or interaction with the database, a user's permission could be granted, and this is why this helps in keeping the data secured from all types of users. What is recovery? In case of system failure, the recovery of information is quite efficiently handled by the DBMS. Now there are few examples of DBMS, that is MS Access, which you will be learning, SQL Server, Oracle, DBase. DBS is not nowadays anymore used here. Nowadays we maximum use SQL, Oracle, MS Access, which is part of MS Office, and FoxPro is also used earlier. Nowadays it's rarely used. Anyway, these are the various examples or different kinds of examples of DBMS. Now the fourth component, a very important, who is going to interact with the DBMS? Definitely software is interacting with the user and the machine, DBMS software. So similarly, user is the one who is going to interact with the DBMS, and via the software it is going to interact with the user and the DBMS. So what happens? Users are the people who access the data. They will access the data from the database to perform their primary business responsibilities. The users could be various kinds of users are there. That could be clerical staff, managers, executives, etc. Now, based on their job profile, these users are given full or partial access to the database data. Database users can be broadly classified into various categories. Like what type of users are there? There could be application programmers. I'll discuss one by one. Next type of users could be end users. Third could be database administrator. Fourth could be system analyst. Now, who are these users and why are they categorized? Because as we discussed that various kinds of permissions are given to different kinds of users, because although the database is shared by many people, same kinds of permission is not granted to all the users. Now, who are application programmers? An application programmer writes application programs to access the data, retrieve the data, update data, delete data, or add new data to the database. These programs are written using a high-level language, preferably SQL. SQL stands for Structured Query Language, which is also known as a fourth generation language. Now, what is fourth generation language? If you remember in your school, you must have read about generation of language. There was first generation of language, assembly level language, high level language, and later on fourth generation language. Now, high level language is also a third generation language, where a compiler is there which compiles or translates the user's code to machine level language. Here also same compilation is also done, but the specialty is it is a query level language. That means the user will ask some query and the software will, based on that query, analyzes the result, matches the criteria and gives the result back to the user. So that is, just because it is a query based language, it is classified into a different group known as a fourth generation language. Now, end users. Who are the end users? End users are those users who use the application programs developed by the application developers. They need not know about the database design, means they are not concerned about how the database is designed, how the database is working, what is the access mechanism and other technical details of the database. They are only known to work with the database, means work in the sense that interact with the database. They just use the application programs. Rather, we can say they just use the underlying database to get their work done. Now again, end users could be classified. They can be classified under two groups. First is sophisticated user, end user, and another one is unsophisticated end user. Now, who are sophisticated end users? They will write their own queries. Queries means questions, to access and process the data stored in the database. Then what is unsophisticated end users? They will interact with the system through an already written application program. They will follow certain instructions provided in the user interface to retrieve data from the database. For example, people working at railway reservation centers or counters will interact with the system through an already written application program. They do not have to write any application program. They just have to interact. Another example of unsophisticated users is bank customers who use ATMs to draw money or check the balance. They are not giving any as such query to the ATM. So they are just using, so they can be classified as unsophisticated end users. Now the third category of users is database administrator. He is a very powerful user. A database administrator, also known as DBA, makes strategic and policy decisions regarding the data. He provides technical support for implementing these decisions and is responsible for overall control of the system at the technical level. Database administrator also monitors and performs all the activities related to database design, implementation, maintenance, as well as security. Besides all this, administrating the database is also the role played by a database administrator. He also trains the employees in database management and how to use them. So the job of database administrator is quite vast. Not only he makes strategic decisions and policy decisions, he also provides technical support for carrying out these decisions and is responsible for overall control of the system at the technical level. Next type of user is system analyst. Now, who is a system analyst? System analyst, from the name you can understand, a person who analyzes the system. Here, what is the job of system analyst? System analyst identifies the end user's requirements, plans solutions, and recommend hardware and software that best meet business goals. They play a major role in database design by writing end users' requirements in a technical requirements definition document after conducting a technical and economic feasibility analysis of the identified requirements. That means, in a nutshell, what we can say, first of all, it will plan out the requirements, then carry out what are the solutions to these requirements, then it will recommend what sort of hardware are required, what sort of software are required that would meet these goals. Then they design the end users' requirements in a technical requirements definition document. In a document, they put down all these requirements. After they carry out the technical feasibility as well as the economic feasibility, it means whether it is worth it economically or technically, whether it's worth it, and then only it will give a green signal. So these are the various kinds of users who are involved in a database management system. Now, our next topic would be database views. Database views sometimes is also called as levels. So let's first discuss what is it. DBMS is actually a collection of interrelated data. That means one data is related with the other. That is why interrelated. And a set of programs that enable multiple users to access, modify, share, and process it immediately. That means DBMS not only is a set of program, but it helps multiple users how they can access the data, modify the data, share the data, and process them at the same time. The main concern of a DBMS is to help users to efficiently retrieve data from the database. Means how well or how effectively and efficiently it can extract or retrieve the data from the database. That is also the work of the database management system. Now, while ensuring efficiency, database developers often end up in designing complex data structure for data representation. Now, since a database is also used by unsophisticated end users, the complexity must be hidden from them, because unsophisticated end users are those who are not aware of any complexities of a database manager. So it is no point that they view all these complexities. So it will create further confusion. So it is always advised that unsophisticated end users who are not aware of this those data should be hidden from them. Moreover, we have seen that there are different categories of users with different needs for the data. Therefore, a very large responsibility of the DBMS is to provide users with an abstract view. Abstract view means certain view where the innermost details are to be hidden. How like innermost details like how the data is stored, how it is maintained, etc. So these are not required for the unsophisticated users. They only know this much data, but that data, how it is stored, how it is maintained, those specifications or those details need not be disclosed to the unsophisticated users. So here comes the role of DBA, that is the database administrator. The DBA then enforces data abstraction in database systems by defining data views at 3 levels. Database abstraction means something which should be kept hidden. So at 3 levels it is done. First is called the logical view, second is called the external view, and third is called the internal or physical view. Although the uppermost level is called the external view. Right? Next layer is called, or next view is called the logical view, and the innermost layer, that is the physical view, is called the internal view. Now these views actually provide a lot of benefit, threefold benefit. We talked about security. This is the viewing part or the database views which provides this security. How? First, it provides an abstract view of data. Secondly, it will hide the complexity from users. Third, it simplifies user interaction with the DBMS. Now, these views again can be described in a different manner, like physical level, logical level, and external level. What is the physical level? Physical level is also known as the physical view. This is the lowermost abstraction that focus on how data is actually stored, the physical arrangement and location of data in the direct access storage device, DASD, direct access storage devices. It describes low-level complex data structure in detail. Database specialists will now use these details to design efficient algorithms to access data and make efficient use of storage and processing resources. Now what will happen? These internal data representation, it's no use to the end users. So actually end users cannot see this data because it's pointless. It is meaningless for the end users to view this, as they are just interested in using the information rather than in understanding the technical details of storage device, where it is stored, how it is maintained. These are not to be of any concern to the users. That is why these things are stored in the physical level. The next level is the logical level. The logical level will describe two different things. The first one, what data is stored in the database, and secondly, the relationship that exists among the data. It is the next higher level of abstraction that focuses on ease of use. The users at this level, usually the DBA, database administrators, are least interested in knowing the physical level complexity used to implement the structure. So at this level, at the logical level, it is the next level, a higher level of abstraction that focuses on ease of use. So it becomes little easy how you use it. So users at this level, mainly because the DBAs are least interested in knowing the physical level complex, means how it is stored, how it is maintained. So they are not worried about that. Now comes the external level. There is a last view, topmost view, or the upper view is, or the topmost view you can say, it is known as the external view or external level. Every user is concerned with a part of data in the database. So external level is actually where all the users are playing, or you can say n number of users are actually in the external level. Depending on the application, the DBMS will support multiple views of the external schema. The external level is the highest level of abstraction that hides all complexities to deal with the user's view of the database and exists only to make it simpler user interaction with the system. Now, as all users and application programmers did not require the entire data stored in the database, the external level describes a part of the database for a particular group of users. It enables customization of data. Customization means depending on the user's needs, the data can be seen by different users in different ways at the same time, means simultaneously. Now, apart from customization of data, the external level also ensures security by hiding the parts of the database from certain users. So the interrelationship among these three levels can be seen as, first is physical level. Physical level interacts with the logical level. External level doesn't interact with the physical level because it's the innermost level. Logical level can be accessed by the external level, and external level comprises of the different users, n number of users, and that is they are having n number of views. So we see that three levels are there. One is physical level, logical level and external level. So this is all about, from here we can find out why these levels are there and why it helps in giving us a security in case of a DBMS. Now this is another part which is more or less similar to this. We call it Three-Schema Architecture. Three-Schema Architecture means the way the structure is made. A database schema is actually a layout of the database or a blueprint that will outline the manner in which the data is stored in the database. It describes, so you can say schema architecture means it describes the structure of a database in a formal language supported by the DBMS. For example, in a relational database, we will discuss relational database later on, probably in the next class. The schema will define the tables, its attributes or fields with the relationships that exist between the fields and tables. Database schema is stored in data dictionary or metadata in textual or in graphical format. Now there could be multiple external schema, but there is only one logical and one physical schema. This is very important to remember, because external schemas means if there are 5 users, 5 will have 5 schemas, external schema. But even if there are 5 schemas, there will be one internal schema, means one internal level, and one physical level. So that is the difference. Corresponding to the 3 levels of abstraction, there are 3 levels of database schema. This is why it is called a 3-level schema architecture, or simply Three-Schema Architecture. They are, first one is physical schema. It describes the design of the database at the physical level. It incorporates the lowest level details that are hidden below the logical schema and describes the physical storage of the database. This can be easily implemented without affecting the application programs that are using the data. The schema is managed by the operating system under the direction of the DBMS. Now let's come to logical schema. What is logical schema? Logical schema describes the database design at the logical level. This schema is often used by the application developers and programmers to develop applications. It is considered to be the most important schema in terms of its effect on application programs. So the last schema which is left, that is the external schema, which we have termed in different ways: external view, external level. Now we talk about the similar thing. When we are talking about schema, we will call it as external schema. The external schema or the user's views are given at the external level. It describes a part of the database as per the user's requirements and hides the rest of the database from the user. In a three-schema architecture, three-schema means we are having these 3 levels or 3 different layers of schemas. So we call it three-schema architecture. What happens here, each user group has its own external view. When a user or a user group requests to generate a new external view, the DBMS transforms the request specified at the external level into a request at the logical level, and then into a request at the physical level. When the user tries to access data from the database, the data must first be extracted, then presented in a format specified by the user. This process of transforming the request and results between the 3 levels of schema architecture is called mapping. Now mapping, I am not going to go into details because this is little beyond your curriculum, but what is three-schema architecture, that I have explained. So what what is the advantage of this three-schema architecture? It ensures data independence, which is the main advantage of using this architecture. It is the ability, data independence is the ability to modify the database schema at one level without affecting or without changing the schema at the other levels. It is of two types, logical data independence and physical data independence. Now let's come and explain what are these two terms. What is logical data independence? It is the ability to change the logical schema of the database without affecting its external schemas or application programs. That means application programs cannot be changed. The schema can be changed due to any of the following reasons, like addition of new fields, deletion of existing fields, addition of constraints, removal of constraints. Now these are the how the logical schema may be affected. Now what is physical data independence? Physical data independence is the ability to change the internal schema without affecting the logical or external schema. An internal or the physical schema of the database again may be changed due to the following reasons: creating additional access structure, changing the storage structure, adding or deleting indexes. Now we know what is indexes, means some numbers, so those are deleted. So we see that both can be affected due to various reasons. The reasons I have mentioned. Now the physical schema is changed to improve the performance of the database system, right? So we have seen logical data independence as well as physical data independence, and both may be changed due to some reasons. In the first case, logical data independence, it can be changed due to addition of new fields, deletion of existing fields, addition of constraints, removal of constraints. And physical data independence may be changed because of creating additional access structure, changing the storage structure, adding or deleting indexes likewise. So generally we can say physical data independence is easier to achieve than logical data independence. This is the reason because application programs depend on the logical structure of the database. Therefore, if there is any change in the logical structure of the database, some changes have to be made in the application programs too. So this is all about, in short for you all now, about physical data independence, how it is easier and why it is easier, and because we have seen the changing of certain features may cause logical data independence effect, and some changes in physical schema or internal schema will make it physical data independence. So the ability to change the internal schema without affecting either logical or external is called physical data independence, and logical data independence without affecting external schemas or application programs. So these two things in short you must remember, so that it helps you to memorize properly. So what is the difference between logical data independence and what is the difference between physical data independence? So next class I'll again just brush up about this three-schema architecture once again. What is the physical schema, logical schema, external schema, and what is this all about, and how it takes place, how it provides, and then we'll shift to the various database models. So as of now, we have discussed what are the components of database management system, what are the different kinds of users, what role each one of it plays, what are the views, what are the different kinds of levels, how each level helps and what is the work of each level, what is three-schema architecture, how it helps, what are the three types of schemas, what is logical and physical data independence. So next class we'll be starting with the database models. Thank you.